Good morning, Tahmina Khan is here in TKMaths S1. In today's video, we will solve a question on vectors, and the concept we will cover is distance from a point to a line. This question is, I have explained earlier, is asked as multiple ways. So this is another past paper question. So let's see. And this concept is from your 13th syllabus A-level mathematics P3, right? So let's see the question. So three parts of the question, we will do one by one. The position vector of vector O, B, C and D is given to you here. So first part, calculate the angle between line AB and CD. Now you know when we are calculating the angle, the important thing is only the direction of those lines, not the equation of the line. So to calculate the direction of the line, I just need to change these displacement vector AB into position vector, which is OB minus OA. Okay, so we will very quickly substitute the values here. I am very much comfortable with the column vector, and in my experience, students find it also easy. So OB is 5 minus 2 minus 2. And OA is I, J is not here, so it will be 0. So 4, 0 and 1. So let's solve this one. 5 minus 4 is 1, minus 2 minus 0, minus 2, minus 2 minus 1 is minus 3. So this is the direction of AB. Now I will calculate CD. Let me change the color so that no confusion. So now we will find out the direction of CD. We will change it into position vector OD minus OC. It's easy to calculate this way. So the column vector of OD minus the column vector of OC. So OD is here, J is again not here. So minus 1, 0 and minus 4. And for OC you can see K is not here. I and J are 1, 1 and 0. So when we will simplify it, it will be 1 minus 1 is minus 2. 0 minus 1 is minus 1 and minus 4. So now we have to find out the angle, and it is saying acute angle between them. So I will apply a scalar product, which is AB dot CD. Okay, and the formula we know, modulus of AB and modulus of CD into cos theta. So AB is 1 minus 2 minus 3 and CD is minus 2 minus 1 minus 4. So modulus of AB, you know, you will square each one of them. 1 square is 1, minus 2 square is 4, minus 3 square is 9. And vector CD modulus will be from here, from this vector, minus 2 is 4, minus 1 square is 1, minus 4 square is 16. So now, you know that in dot product, when we multiply x by x, y by y, z by z. Okay, so minus 2 plus 2, because this is minus 2 and minus 1 is 2. Similarly, 3 4s are 12. This one will be 14 and 21. So let's take the calculator and calculate it quickly. It is 12 divided by, I'm multiplying 14 by 21. 14 times 21 is 294. And then I will take cos inverse to calculate the angle. Okay, so cos inverse, you can take the calculator and you can also do it. 12 divided by 294, and I got here the value, which is 45.6. So angle is 45.6, and question was saying find the acute angle here. So we have found it. Part 1 is done. Part 2 is saying prove that line AB and CD are not intersecting. Now, this is again a very, very important concept. Let me change the color here. Now to find out that lines A, B and C, D are not intersecting, I need the vector equation of these lines, right? So first of all, let's find out vector equation of line AB. Vector equation of line AB, which is what? R equals to A plus lambda B. Now A is any fixed point, your choice. From A, B, suppose I am taking A, right? So this is 4, 0 and 1. 4, 0 and 1. Lambda, for line AB, suppose this is my line AB, I can take any point, either A as a fixed point or B. I have taken A, right here. Choice is yours. And B is the direction vector, so that is AB. AB we have calculated up here. 1, minus 2, minus 3. So 1, minus 2, minus 3. This is my vector equation of AB. If I write it in the XYZ form, so let me just erase this, okay? So it will be 4 plus lambda, lambda 1 is a lambda, 0 minus 2 lambda, and then 1 minus 3 lambda. So this is my XYZ coordinate of vector equation of line AB. Now I will find out for CD, okay? So I will use it on this side. Okay, so now CD. Again for the CD equation, vector equation again, first of all I'll find out vector equation of line CD. So it will be, suppose R equals to A plus, instead of lambda let me use mu B, okay? A is my any fixed point, either C or D. Suppose I'm picking up C. It will be 1, 1 and 0. 1, 1 and 0. And B is the direction of CD, which you have calculated here. This is the direction CD. Minus 2, minus 1, minus 4. So minus 2, minus 1 and minus 4. So I will change it into XYZ coordinate. So it will be 1 minus 2 mu, 1 minus mu and 0 minus 4 mu. So now these are the XYZ coordinate on line CD and these are of ABC. Because we have to find out the intersection point according to the question. So what I will do, I will equate X coordinate with X and Y coordinate with Y. So this one will equate with this with this. You can pick up any two. So suppose I am picking up this one and this one, okay? So I will solve them simultaneously. So 4 plus lambda equals to 1 minus 2 mu. Another I am taking 0 minus 2 lambda equals to 1 minus mu. I will solve them simultaneously. I will get the value of mu and lambda. Then I will plug in the third one, this one, and I will show you what. So let's make mu a subject from here. It will be 1 plus 2 lambda. I am going to plug in this one. So 4 plus lambda equals to 1 minus 2, 1 plus 2 lambda. So it will be 4 plus lambda, 1 minus 2 minus 4 lambda. So I'm bringing lambda here. It will be 5 lambda equals to minus 1 minus 4. So lambda equals to minus 5 upon 5, which is equals to minus 1. I will plug in the value here to get the value of mu. So it will be 1 plus 2 minus 1. 1 minus 2 equals to minus 1. So my lambda is minus 1 and my mu is also minus 1. I will plug in these values in the third value of which is z, and if I get same answer, it means lines are intersecting, right? So let me substitute it 1 minus 3 lambda, the value of lambda, and minus 4 mu, the value of mu. Okay, so now it is 1 minus 3 minus 1. So 1 plus 3 equals to 4. I got answer 4 here. let me substitute this one. So minus 4 minus 1 is also 4. Because my answer is same, it means lines are intersecting. So this is how you prove. You can select any two. I selected first two and substitute in the third one. If you are solving suppose second and third simultaneously, then you will put the values in the first one to check if the answer is same or not. So let's do the last part. Last part is tricky. We have to find out the position vector, perpendicular distance from P to the line, AB. Okay. So part 3. Suppose this is my line AB and this is my point P. I have to find out this perpendicular distance. Let me call it F. So the whole target will be to find out PF vector and then its modulus. That will give me the distance. This is the question all about. Okay. Now there are few things. Let's see what is the point P given to you. Point P is given to you 1, 5 and 6. Okay, I'm writing in the column vector form. 1, 5 and 6. This is P given to you. Suppose this is your O, origin. Okay. The line AB you have calculated here. Here. Okay. So I am using it from here. 401. I'm writing here using some other color. So let me use red. So the line is 401. I'm talking about this line AB, okay? Lambda 1 minus 2 minus 3. Lambda 1 minus 2 minus 3, right? This is the equation of the vector line AB, and 1 minus 2 minus 3 is the direction of the line. We have to find PF. So let's say start. PF, we will start in the order. So vector PF, if I change into position vector, it will be OF minus OP. Right. Now OF, if you see from here, is any point on the line AB. I'm repeating, is any point on the line AB depending on the value of lambda. So whatever is the equation of line AB, okay, if you take the same equation AB, different positions, different values of lambda will give you different point on it. So you can say your OF is actually this same thing. 4 plus lambda, I'm taking from here, 0 minus 2 lambda and 1 minus 3 lambda. Did you understand why I'm saying so? Because OF is any point on the line AB, so value of lambda will determine different points here on the line AB with respect to origin. Okay, so that's why I have just written this AB line in this form. Okay, now OP is 1, 5 and 6. Now I will simplify it. It will be 4 plus lambda minus 1 minus 2 lambda minus 5, 1 minus 3 lambda minus 6. Let's simplify it further. It will be lambda plus 3 minus 2 lambda minus 5 minus 3 lambda minus 5. Now I have PF here. If I can find out the value of lambda, then I can simply take the modulus of this. Now how will I find this value of lambda? This is the question. Now if you see here, this PF, right, and this direction of the line are making 90 degree. I'm repeating, this PF and this direction of the line are making 90 degree. PF I have and direction of the line is here. So I will take a dot product of these two. What will I do? I will take a dot product of these two. So I will say vector PF dot with 1 minus 2 minus 3 will be equals to 0. Because perpendicular vectors dot product is equals to 0. So now I will write here vector PF, lambda plus 3 minus 2 lambda minus 5 minus 3 lambda minus 5 dot with 1 minus 2 minus 3. Okay, so now I'm going to take or make the equation. You know how to solve it? This into this plus this into this plus this into this. Okay, so I'm doing here lambda plus 3 times 1 minus 2 times minus 2 lambda minus 5 plus minus 3 times minus 3 lambda minus 5 equals to 0. And then I'm just simplifying it. I hope I will not make any calculation mistake. You can also stay alert with me. So lambda 9, 10, 10 and 14. 14 lambda. And this is 15 plus 10 is 25, 28. Okay, minus. So lambda equals to minus 2. Now you got the value of lambda. Now I will plug in here so that I can get PF straight away. Okay, so I'm going to substitute it here. Let me change the color again, black. Okay, so suppose I have PF and I will substitute the value of lambda here, minus 2 plus 3. Okay, I'm just substituting this value in this equation. So minus 2 times minus 2 minus 5. And do not do very direct work. You may make mistakes. So write one extra line. At least you will avoid the calculation error. So this will be 1. This is plus 4. Minus 5 is minus 1. This is 6 minus 5 is 1. So you got your vector PF. Now you just need to take its modulus because you have to find the distance. And distance you get by taking the modulus. 1 plus 1 plus 1. Because you are squaring each one of them, remember? So your answer is root 3. So what was question asking? Okay, so it was saying show that it is root 3. So we have proven here that it is root 3. So you can just write here proven, and that's all. So thank you very much for watching. I hope you understood. If you have any question, you can write it in the comment. I will try to explain. Thank you very much. Take care. Please press share and like button. Thank you. Allah Hafiz.